Good. Well, thank you very much for taking the time to talk to us. I'm interested, perhaps first, if I can get your opinion on what impact this regulation will have on the industry as a whole, OEMs, suppliers, how that will impact the buyers of vehicles as well.
Yeah, actually, from my perspective, at least, I think this is a good thing that the regulation is in place. On one hand, it's going to actually push the suppliers of efficient technologies to actually continue down the path of innovation, pushing the boundaries of the technology, both from a performance standpoint, again, reducing emissions, saving fuel, but also from an affordability standpoint. The payback has to be there. The economic equation has to make sense. So generally speaking, I think it's a good thing. I think the OEMs, for example, are going to have an incentive to implement and adapt these new technologies faster. That's important because we need to get the technologies in the hands of the end users faster, increase the volumes, leverage the economies of scale, and mature the technologies even to even get even faster, better performance beyond what the regulations are pushing for. From a supply chain standpoint, I think I started saying that it's very helpful to, again, incentivize people, the supply chain, to go and put in place the systems, the technologies, the production processes that are required to make the products in support of this regulation mainstream, as opposed to being the exception to the rule, so to speak.
Okay. What do you think will be the key trends to emerge as a result of this legislation coming in? Perhaps the trends before 2014 as buyers start to change their purchasing strategies, and then after 2014?
Honestly, I think the trend has started already because before the regulation was put in place, the need to save fuel, reduce operational costs, and the ownership, the cost of ownership of the fleets and vehicles in general have been a driver behind reducing fuel and therefore the associated emissions. So the trend has been that we are in a phase where between now and say 2020, 2025, there's going to be a coexistence of multiple technologies, hydraulic hybrids, electric hybrids, improved engine operation, accessory management at the vehicle level on the engine side as well. And as we go beyond 2025 in the next 2 decades, then we're going to see a convergence towards more EV, electric vehicle type of technology. Because in the end, EV makes sense from both the emissions, greenhouse gases, CO2 standpoint, but also fuel economy, because energy security is another driver behind trying to make these technologies mainstream. The demand for natural resources is increasing. The supply is not there. The rise of economies like India and China are actually putting a lot of pressure and stress on the supply side of things. So alternatives to the mainstream or the oil, so to be more specific, is critical just from that perspective. So that's the trend. It's really going to be coexistence of multiple technologies and a convergence towards the EV end state in the next 2 to 3 decades. And the coexistence of these multiple technologies initially is critical because that's what we call the bridge technologies. We need the hydraulics, we need the electrics, and we need the electric accessories, and we need the advanced engine management, biofuels. All of these need to be put in place to stimulate the adoption of alternative powertrain technologies for propulsion of vehicles and establish the required supply chain infrastructure in support of the end state of the EV, which is the EV.
Thank you. Have you seen an increase or a trend in favor of deeper collaboration between OEMs and suppliers in order to meet this regulation?
Actually, that has been, it's an excellent question because so far the people who have been successful in providing alternative technologies, propulsion technologies, have been the ones that have been collaborating and working very closely with both the OEMs, the end users, and the supply chain. So again, that's been so far the exception to the rule, but the winning exception. As we go forward, I think it's going to be the mainstream behavior because reducing cost, increasing volumes, increasing or accelerating adoption of the technology will require that all these team members to work very closely together so that, again, in the end, the final product is affordable and it provides the performance in terms of, again, fuel economy, reduced emissions, but also economically will provide the payback based on lower costs of ownership and lower operational costs in general.
You mentioned cost, and that's the big factor here.
Yes.
All we ever hear is that OEMs want to drive suppliers down, suppliers want to drive their suppliers down in terms of product development costs. How can you help OEMs? Can you work closely with them right from the start of R&D programs? Are you seeing a willingness for them to bring you in to do this?
Absolutely. Again, some of the things I'll be covering in my presentation this afternoon will focus particularly on the criticality of, at the onset of a development program, of a propulsion technology, hybrid or other, it is critical to get the OEM on board as well as the end user. The end user will give you the specifics related to the definition of the application, the duty cycle, the expectation in terms of performance, and what they want to see as a payback. The OEM will basically facilitate the development of the technology because in the end, that technology has to be integrated into the vehicle. And the vehicle configuration, constraints, packaging, weight, payload, and so on, all those things must be accounted for as you develop the technology so that in the end it meets both the end user as well as the OEM's expectations, again, from cost and performance standpoint. Trying to basically appease or meet the requirements of the supply chain, the end users, the OEM, is really the way to go to get a product that is affordable, that people will stand behind, and that the end user will be happy to use and buy and purchase.
Okay, thank you. My final question, this regulation on fuel consumption and greenhouse gas emissions applies to the US.
Mm-hmm.
The technology that you're developing, are you seeing that being deployed elsewhere in the world, in other regions where they're also trying to meet similar levels and targets?
Absolutely. If you look at Europe, Euro 6 is going to come out in a year or so. It's going to become the standard. And if you look at, for example, I'm speaking of my company, BAE Systems, the technologies that we've developed over the last 20 years have been deployed in North America. The transit bus has been our main market, and we're coming up with a new product that targets the heavy-duty truck market. Those technologies were successful in saving fuel and lowering cost of operation and ownership, as well as reducing emissions in North America. And in the last 5 to 7 years, we've seen a great interest from Western European countries to go and adopt those technologies. Today, we have buses, hybrid buses operating in London, in France, Oxford in the UK, beyond London, and so on and so forth. So there is definitely a trend and interest in leveraging what's been demonstrated and matured in North America back in Europe, because although the standards might differ to some extent, the actual end result that's sought after is really the reduction of emissions and fuel consumption. And the beauty of hybrid electrics that we supply, for example, is that the control laws are flexible. So depending on what the specifics of the rule or the standard are, you can go tune that technology to meet those specifics without necessarily having to redesign the system from scratch, which again leverages the economies of scale and reduces cost of development and accelerates the adoption of the technology.
Right. Okay. Thank you very much.
You're very welcome.
Thank you.